Alrighty, day 8, properties of the quadratic relation. So in the previous lesson, you learned how to tell the difference between linear and quadratic based off of what the equation looks like, aka having an x squared, what the graph looks like, so that U shape, which we call a parabola, and being able to tell between the first and second differences on a table of values. So if we think back to what we've learned in grade 9 about how to fill out a table of values, your x value is like your input, and your y value is like your output. And what that means is if you just replace x with the number, -3, and here's your equation, which is y equals x squared, we're going to get 9. So that's your output value. And we do that for all of our input values. One squared equals 1, 2, 3 squared equals 4. Oh, 0 squared is 0, sorry about that. And then 9 again. And then we do the first differences. So we subtract the bottom from the top. So 4 take away 9 is -5. Just write that up there, but I won't write it every time for each one. 1 take away 4 is -3. Then -1, then +1, then +3, and then +5 if I go all the way down, okay? And you'll notice they're not the same, so it's definitely not linear. And if we do the second difference, where we take the difference between the first differences, so what that means is I'm going to take that -3 and subtract that -5, I'm going to get +2. Actually, I'll just draw it down there, 2. And these guys, if I subtract them, I get 2. It's very important that you remember that you're subtracting from the bottom to the top. So 5 take away 3. Okay? And you'll notice that they are all 2. So when all of the second differences are the same, we know that it's a quadratic relation. So that's review of grade 9 and review of last lesson. And now I'm going to draw an axis. And I drew my y-axis down the middle because I know that my x's are, some are negative and some are positive, so either side of that line. And then where I'm going to draw my x-axis when I graph it out, I know my least number on my y input is 0 and the highest is 9, so I'm going to bring it down towards the bottom. Now don't forget, when you're drawing your axis, they have arrows because they go on forever, and we have to label our x and y axes for communication marks. So I'm going to switch my pen color just to kind of highlight that your table of values is x for here and y there, and I'm going to plot them. So I've got -3, and I'm just going to assume that my scale is 1 to 1. So really I should, guess I'll do like, oops, didn't mean to erase that. I meant to change my color. There we go. So that's 5, and that's 10, and this is -5, and this is +5. Okay, so it's a 1 to 1 scale. And I'm going to plot my points. So -3, 9, which is here, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. Okay. And you'll notice that it's in that U-shaped parabola. Now, when we draw parabolas, a lot of the times it can get really messy, and I see parabolas that look like V's with very sharp points. We definitely don't want sharp points. We want nice and curved points. Okay, a parabola is a U, not a V. So, to do that, here's my trick. If you start at the turning point at the bottom here, and we draw a nice U, a U shape, that is going to help deter from the V that we kind of naturally just start drawing. And then we can draw our curve connecting the points. And you go a little bit beyond your last point and you draw an arrow because it goes on forever and ever. And same with this side, we're connecting our points now. And that's our parabola. And then we have to label it for communication marks so that I know the equation of that graph, which is y equals x squared. So looking at our table of values and our graph, let's answer some of these questions below. First one, what do the first and second differences tell you about the relation? Well, if the second differences are all equal, it is quadratic. Interesting. Jumping around on me. Okay. So second difference. Maybe I'll write it on the side here. How's that? Is the value of A positive or negative? So we're going to get into that a little bit more next class, but the A value here, whatever that value is, if it is, if A is positive, your parabola is happy, so it opens up like that. If the number A that's in front of it is negative, then it's sad. So it's a sad face. Okay, so it's going to open down. So A is positive. Okay. What does it tell you about the graph? That it opens up. So we will go down here. A, if we look at, is actually positive 1, right? So when A equals 1x squared, the 1 is there even though we don't write it. So A is positive, therefore it opens up like a smiley face. What is the location of the vertex? So the vertex is this point there, and just tell me the coordinates of that point, which is 0, 0. Is the vertex a maximum or a minimum value? And that means, is it the highest point of the parabola or the lowest point in the parabola? And it's the lowest point, right? Our red graph, our red curve here, doesn't go lower than 0, so it is a minimum. What are the zeros in the relation? And the zeros are like our x-intercepts. So our x-intercepts, it's actually our x-intercept is our vertex in this case. Doesn't always happen. There's only one. Sometimes, most of the time there are two. Okay, and then we're just going to go to the next one, and we're going to do the same thing. We're going to answer the same questions. We're going to graph it the same way. This would be a great opportunity for you to practice and just kind of go with your intuition and what you think. So pause the video now and just try it and see what happens. All right, so just a reminder, x is our input, which means that it's going to look like this. Now, I don't really expect you to do this every time. In fact, I'm just going to move this up. There we go. In fact, I think that it would be better if you try to get used to not writing it out every time. However, we're just starting this, so go for it. So this would be 9 plus 12 minus 5, which is 16. Then we do the same thing. So I'm going to skip the first line, but I'm going to write down the second line. So I'm going to do the squared, this, and I'm going to do the multiplying in my head and write it down. So negative 2 squared is 4. and then negative, oh, see, I already realized a mistake. This was negative 3, which changes this to negative 12, and then we have negative 8 instead. So negative 2 squared is 4. 4 times negative 2 is negative 8, minus 5, which is minus 9. Did I do my math right above? No, I did not. Yeah, I did. Okay, just checking. Negative 1 squared is 1, minus 4, then minus 5, which is negative 8. And then, okay, I see. And then 0 times 0 is 0, plus 4 times 0 is 0, minus 5, which is negative 5. And then this is 1 plus 4 minus 5, which is 0. And then this is 4 plus 8 minus 5, which is 7. And then we've got 9 plus 12 minus 5, which is 16. Then we take our first differences. So I'm subtracting these, which is negative 1, positive 1, minus 3, oh, sorry, positive 3, 5, 7 minus 0 is 7, 16 minus 7 is 9, and then I do my second differences, which is 2, 2, 2, 2, and 2. It looked like I didn't do that in my head, but I swear I did do that in my head, okay? So I did calculate them. I'm not just writing 2 all the way down through. Please don't do that because there might be something like on a test where it looks like the second differences are going to be the same number, but then all of a sudden it's not. And that can either mean two things. Either you did it wrong and go back and look for mistakes because it is a parabola, and it is quadratic, and I know that it is quadratic, so because this is x squared, so the second differences should be the same number. However, sometimes you just need to make sure that you double check that, okay? So I'm going to sketch this out. Now I'm going to look at, I know my x-axis is still even left and right, so that means my y-axis will go down the middle. However, if I look at the biggest number for y, which is 16, and the lowest is negative 8, whew, I'm going to do it kind of in the middle. I'm going to change my scale. So I think, let's see, 16. I'm going to go by twos, right? 2, 4, 6, 8, 12, 14, 16, negative 4, negative 8. And I'm going to stick with one across each side. So this would be positive 5, this would be negative 5. Okay, and then I'm going to plot my points. I'm just going to use a different color to highlight that. So negative 3, negative 8 is here. Negative 2, negative 9 is here. Remember your scale. 0, negative 5, 1, 0, 2, 7, and 3, 16. So again, we can see our turning point, and that's here. And we know that it goes all the way up this way. And I'm going to write my equation, x squared plus 4x minus 5. And you'll notice that it looks like a Nike check, but it actually goes back up the way we came. And we know, because it is a parabola, one of the properties of a parabola is that it is symmetrical. So if you kind of imagine this like a line and then I reflect everything over across that line, I can actually draw the other points. So I can extend it and I know that it's going to be 1 over, it's going to be here. I'm just doing like a different color just to show you that I'm adding it there, there, and then there. And you can see that it's mirrored, right? So if I connect it, it actually looks like a parabola. So the purple ones I added just to show the symmetry of our parabola. Again, what do the first and second differences tell you? Well, because the second differences are the same, it's quadratic, so I'm not going to write that again. Is, because it's the same as before, is the value of A positive or negative? So we're going to say quadratic because of second differences. A is positive because it is happy. And what does it tell you about the graph? That it opens up, right? The opening is upwards. The location of the vertex, which is that point right there, which is -2, -9. Is it a maximum or a minimum? Is the vertex the highest or the lowest point? It is the lowest point because we cannot, nothing exists down here, right? We cannot draw anything below that. So it is a minimum. And what are the zeros? Okay, so our zeros are our x-intercepts. Remember, our zeros are our x-intercepts. So wherever our vertex crosses the x-axis, which is here and there, and so we have 2 points to write down. The first one is -5, 0. And the second one is 1, 0. Okay, and we write them as points. We don't say -5 and 1. We write them as coordinates, just like we would any other point.